Welcome back to Applied Mathematics. In this video, I want to review solving equations. There are many different kinds of equations that can arise in mathematics, most of which I expect you have never seen before, some of which I am planning on introducing you to later on in this course, but for right now, I want to review three kinds of equations that I expect you have seen before. Right. I don't think this requires any further introduction, so let me get my head out of the way, and we'll start off with a linear equation. All right, so for example, maybe we'll look at 3x plus 7 is equal to 25. In order to solve this equation, we're going to use two nice properties of algebra. First, the additive property, which will allow me to subtract 7 on both sides of the equation. When I do that, 3x plus 7 minus 7 simplifies and is just 3x. On the right-hand side, 25 minus 7 is 18. And then the additive property of equations, the multiplicative property of equations, which tells me that if I divide by 3 over here and I divide by 3 over here, I still have the same equation. And let's see, 3x divided by 3, multiplying by 3 and dividing by 3 cancel each other out. I'm left with just x. 18 divided by 3 is 6. This process works equally well if you're dealing with an equation that has approximate values in it. You just have to remember all the rules of rounding. So if I have something like 2.75 minus 4.4x is equal to 19.3, I can go through using the same rules. Let's get rid of that spare dot so that it doesn't distract us. And I guess step 1 is going to be subtract 2.75 from both sides of this equation. 2.75 minus 4.4x minus 2.75, the like terms combine and cancel each other out, leaving you with minus 4.4x. And then on the right-hand side, my calculator will tell me that 19.3 minus 2.75 is 16.55, but because I'm subtracting, I want to use the precision rule, which says that, well, my worst precision is the nearest tenth, and I'm going to call this 16.6. Now, to get x by itself, I want to divide by negative 4.4 on both sides of the equation. On the left-hand side, negative 4.4 times x divided by negative 4.4 was just going to leave me with x. On the right-hand side, 16.6 divided by negative 4.4, my calculator tells me is negative 3.772727, etc., etc., etc. Rounding here is going to be based on accuracy, the number of significant digits. And 4.4 has the worst accuracy with 2 significant digits. So I'm going to round this and call it negative 3.8. And that's all the more accuracy and precision that I get in my solution. And there we have it. The second type of equation that I want to talk about today is a proportion. All right, a proportion might say something like x over 7 is equal to 3 over 9. And to solve a proportion, you use the cross product test. You take the things that are diagonally across from each other and multiply them together. In this case, that means it's going to be 9 times x, and it's going to be 3 times 7. And if the fractions are equal, then these are also going to be equal. Right? And then reducing the fraction. Again, exact values to start, so I'm going to get exact values at the end. X is equal to 7/3. We can do this just as easily if we have a proportion that has approximate values in it. Let's say 1.2x over 2.54 is equal to 13.37 over 14.49. So we'll have 1.2x multiplied by 14.49 on one side of the equation, and we'll have 2.54 multiplied by 13.37 on the other side. Paying attention to my rule of accuracy, on the left-hand side, after I multiply and round, I'm just going to call that 17. On the right-hand side, after I multiply, I get, it looks like that's going to be 34.0, keeping my 3 significant digits. And then to get x by itself, I divide. Right. Interestingly, 34.0 divided by 7 comes out as exactly 2, but it's not exact, it's an approximate value, so I still need to keep my worst precision, which is 2 significant digits, and call it 2.0. One of the things that can be really messy dealing with a proportion is when there is more to be done. So if I have something like x plus 1 over x minus 1 is equal to 5 over 9. And at this point, I'm going to go back to working with exact values because I don't want the approximations to muddy things up. This is complicated enough as it is. All right, but using the cross product test, I will have 9 times x plus 1, and I will have 5 times x minus 1. Using the distributive property, 9x plus 9 is equal to 5x minus 5. Right. I've got x's on both sides of the equation. Well, that's a bit of a problem, but it's not too bad of a problem because I can just subtract 5x on both sides of the equation. 9x minus 5x is 4x. 5x minus 5x is 0, leaving behind the minus 5. All right, now from here, I'm running low on space, so let's just continue over in another column. I'll rewrite my 4x plus 9 equals negative 5 before I subtract 9 on both sides of the equation, giving me 4x equals negative 14, and then I divide by 4, giving me that x is negative 14 over 4, which would reduce, and I can call it 7 over 2 instead. All right, the last type of equation that I want to look at is the simple squaring equation. X squared equals 144. If there's more involved, if you have an x squared and an x in the equation, then instead of a squaring equation, that would be called a quadratic equation, which we'll talk about later on in the course. But for right now, we're going to stick with the easy variant, the squaring equation. X squared equals 144. If I can hit the button to get my head back out of the way to approach a squaring equation is to use the square root property. If x squared is 144, then x itself is either the positive or the negative square root of 144. And the square root of 144 is 12. All right, that positive or negative is important because 12 squared is 144 and negative 12 squared is also 144. There are two solutions to this equation. That said, if this equation came out of an application, it might be that only one of those solutions is appropriate. Right? Very often you see equations like this when you're solving a circle. If you're given the area of a circle and you want to find the radius, you're going to have to use this property. But then you'll have the extra step of, well, it's a radius and there's no such thing as a negative radius, so I guess the positive branch is the only one that's reasonable. If the application that gave you the equation gives you the ability to do that, then you can do that and it helps you in solving the problem. But that's different from solving the equation. The solution to the equation has the positive and the negative branches. I know that's kind of getting to splitting hairs at this point, but right now we're just looking at solving equations. We're not looking at applications. There is no context to tell you whether one or the other of the solutions is nonsensical. All right. I could do this again with approximate values and so on, but I think that's probably good enough. So I will wrap up with this. As always, thank you for joining me. I'll see you next time.